Greetings, M squared here, and today we are going to talk about using models to answer some questions. So we're going to do exponential models. Now, previous to this, we've already talked about what growth and decay mean, and this is the key right here to whether it's a growth or decay model, whether you add the rate as a decimal or subtract the rate. So when you're adding the rate, it's growth. That means b is greater than 1. When b, or the rate, is between 0 and 1, it's a decay model. So either we're increasing as x gets larger or we're decreasing. So when we talk about exponential growth, it's an increase. When we talk about exponential decay, it's a decrease. A lot of times we use population. We use this model for population growth. So in our first example, the population of Hillville grows at an annual rate of 15%. What will the estimated population of Hillville be in 5 years? So remember that we need a beginning amount, we need a rate, and we need a time. Those are the three things we need. The A is the beginning amount, or the initial value. The R is the rate, and they usually give it to us as a percent that we need to change to a decimal. And this little exponent, sometimes it's a T, depends, sometimes that letter changes. This is our time. So we want to know what the population currently is. It's 5,000. So let's set up our model. F of x equals 5,000. That's our initial value. Our rate is 15%, and because it's growth, we're going to add the 15%. Remember, I changed that to a decimal by dividing the percent by 100. And our time in years is 5. Now, the tricky part to this, I'm setting up the equation because we've already learned how to do that. And we've learned all the parts. That's not the tricky part. The tricky part is figuring out what your calculator should be doing. So I'm going to get my calculator out and show you what that is. So I want you to make sure you have your calculator out and that you know how to enter in your calculator. So I know that the beginning amount was 5,000. Then I start with my parenthesis. I had 1 plus 0.15. So I'm going to say 1.15 because when I add those together, that's what I get. And then I'm going to end my parenthesis, and I'm going to use this little caret symbol right here. Some of you might not have a caret symbol. You might have like an A to the B key where it brings the next thing up to an exponent. That's the key you want to use. And it said 5 years. So that's how I put it in my calculator, and I'm going to press enter. And I get 10,056. And sometimes I don't use this part because it's a part of a person when we're talking about population. Sometimes the directions will say round to the nearest person. It depends on what your teacher wants you to do. But I'm only going to use that little part right there, or we can round to the next person. Okay, so in this one, I'm just going to use the 10,056. But watch the directions because sometimes it's different. And I'm going to say people, because we're talking about a population of people. Okay, let's go on to our next one. So here we're doing a population model, but we're talking about picas or picas, and the number of picas in a region is decreasing. So that's our hint that we're going to have a decay model. How many picas will there be after 5 years? Okay, our year, right? This is the important part. Year is 5, initial population 144, and then what's our decreasing rate? It says right here 8%. So to set up my model, I say y equals the initial value, 1 minus, because it's decay, and 8% as a decimal is 0.8, to the 5th power. Because you could put an x there, but if you're finding it out in 5 years, which is what they asked, that's where the 5 goes. So we got to figure out what 1 minus 0.808 is. That's like $1 minus 8 cents. That's going to be 92 cents. So we're going to change that so we can figure it out. Okay, so what I'd like you to do is pause the video, plug that in your calculator, and see if you can figure it out before I do it. Okay, hopefully you paused your calculator. We're going to say 144, and then in parentheses 0.9, and then to the, remember we're going to use that caret key, to the 5th power. And what do we get? We get 94.9. So let's say this one, they said, hey, round to the nearest pica. So we're going to say 95. So we'd say 95 picas. in 5 years. That's how many we'd have. Okay, we're going to try a few examples, and on each example, I want you to maybe look at that problem. I'm going to read it, pause, try to set up the equation by yourself, and then try to do it by yourself, and then come back to the video. Okay, the cat population in Stillwell, Kansas drops. That's our decrease, right? Drops 4% each year. Currently, the population is 570. Write a function that gives the cat population size, C of t, t years from today. Okay? So that's your cue to pause, and I'm going to continue on. So C of t, they gave us the function name. So the function name is C, t is going to be our variable. So the initial amount is 570. It's a decrease, so it's going to be 0.04, and it's to the t years. So that is my function model. Now the question says, hey, use this equation that you just made to predict the population of how many cats there will be in 15 years. Well, since this is years, this is the time, that's our t, all we do is take this model and put a 15 right there. And I usually clean this up, I actually subtract. So that means in your calculator, whoops, you would take 570 times 0.96 to the 15th power. Is $1 minus 4 cents, $1 minus 4 cents is 96 cents. So we are going to take 570, and in parentheses, we're going to put 0.96. And we're going to take that to the 15th power. And we get 308.9. So we'll say we think there's going to be 309 cats. That's our prediction in 15 years in Stillwell, Kansas. Okay. We're going to read the next one. Again, pause. I want to make sure you know how to use your calculators because that's really the trickiest part of all this. There are 20 bacteria in a petri dish. There are 20 bacteria in a petri dish. Well, that should say dish. Dish. Sorry about that. The bacteria will double every hour. So there's our time, right? This time it's hours. It's not years. Write a function that gives the number of bacteria after t hours. Okay. Pause if you need to. So here we go. F of x. It didn't give us a model name, so we'll just use f of x. The initial was 20. It doubles. What does that mean? It's kind of like if you had 1, 1 plus 1 is 2. It's like 200%. So doubles always means a 2 because you had 1. The next time you got 2. So that's why the 2 goes there. Every hour, so we're going to say after t hours. And then it says down here, well, what about after 1 day? Okay, well, you got to be careful when the time changes because they gave it to us in hours. Now they're saying 1 day. That's why I put 24 hours there because that can be tricky sometimes. So I'm going to take my model and I'm going to use it. And instead of t, I'm going to say 24. Okay, so I'm going to take 20. And we're expecting it to be a big number, right? I mean, you get 20, then 40, then 80, then 160, and you haven't even gotten to half the day yet. So we're going to expect that to be kind of large. When something doubles, it goes up pretty quick. So we would say, whoa, that's a lot, right? So that's 335 million. It didn't tell us what to round to, but I'm just going to say 335 million and ignore the rest. And if it tells you to round to the nearest ones, you can do that. Just watch your directions on that because the directions are super important. Okay, then last problem. Caleb started a new job making $51,000 per year. Each year, his salary should increase 3.5%. Write a function that will represent his salary in X years. Okay, we have our X years, we have our starting amount, and we have our rate. And this is an increase. So we start with 51,000. We're going to increase it 3.5%, which I need to change to a decimal. Sorry about that. And we have X years. So here's our model. It says after 10 years, what should his salary be? Okay, so all we have to do is put 10 in there, right? Years, we're good. So 51,000 times 1.035 to the 10th power. So we put that in our calculator. In parentheses, 1.035 for our 3.5% to the power of, and what was that? 10 years? 10 years. And it looks like that's going to be $71,940. And if we had rounded to the nearest dollar, we should probably put that at 1 because it said a 5 there. Okay, that is your modeling for today's assignment. So you want to make sure that you are able to do that before you get started on your assignment. Make sure that you're getting the answers I got from the calculator before you get started. And then the assignment should be fairly simple because you just need the initial amount, the growth or rate, add or subtract depending on if it's a growth or decay. And don't forget your little exponent. Good luck with that. M squared signing out.